All right, ladies and gentlemen, welcome to our next session here. We've got Michal Spacek. Awesome, awesome. He ridiculed me or, made me make fun out of myself for getting that wrong the first couple of times around. So anyway, we've got the problem with the real world, which we all know that's a lot of fun in relation to passwords and capital P, password1, everybody's favorite Windows password. Password 2, yes, or 2014, one of those, All right, so everybody welcome. Thanks for showing up. Give it up for Michal here.
Just trying to. Okay. Hi everyone. My name is Michal, and I'm actually not a password professional. I don't crack passwords. I don't know much about passwords. I'm a web developer. I try to implement all the stuff that you clever guys are throwing at us. And I would like to tell you a story about trying to implement all the security stuff and trying to implement or improve password security at one of the biggest Czech e-commerce sites. So it's a true story. We have done that, and I will tell you what went wrong and what we have learned about users and about their behaviors. So yeah, all of these are true stories. They are not really in chronological order, so it could happen in a different order back in time, but that doesn't matter. So the name of the talk, The Problem with the Real World, is actually an unofficial part of the trilogy. There have been talks in Bergen last year, The Problem with Passwords, and another talk was The Problem with Users. So I thought that, okay, let's make it a trilogy and call it The Problem with the Real World. Yeah, I will tell you what worked and what not. It might sound a bit like complaining towards users, but I'd rather call it a reality check. So I'll talk about a site which is called Slevomat. It's a deal of the day type of site. It's like Groupon. It's the biggest Czech site of this type. It's actually doing, the revenue is $50 million in last year, so it's kind of big for Czech Republic. Czech Republic has like 10 million people living there. So this company is kind of big, and this company has 150 employees. Its database is around 1.8 billion user accounts in the database, and the company has like 1 million customers. It's probably some of the users, actually, some of the customers have more accounts, but that doesn't matter. It's running on PHP and MySQL, and why to actually protect the user data? Of course, just because of the passwords, but there's another reason. It's that the users have also stored credit cards. The cards actually are not stored at the site. They are stored at the payment gateway, but still, if somebody would steal another user's account, they just can buy stuff using his credit card. Even if the card is not actually stored at that site, it's stored in the payment gateway and it's used via the API. The attacker can still buy stuff using the credit card. And yeah, this company is a market leader in the daily deal business. So the company wanted also to lead by example in a different area, because it has some positive hiring things as well. If the developers see that the company is doing stuff in the right way, they might try to join as well. So yeah, I joined this company last September, and I actually already left, but it's not related to this talk. Back to that later. So yeah, I joined as a web developer, not as a security guy, but I saw that there was a lot of stuff done in a suboptimal way, to put it this way. And so I started to fixing it with some other guys in the team. And yeah, it was a lot of issues. So one of the first issues was that, the passwords were stored and in a not really nice way. It was stored as a SHA-1, unsalted. So yeah, we had to fix that. We didn't try to crack the passwords of the users, because we said that, okay, it's not our job, it's somebody else's job, probably Per's job and Jeremy's job. But yeah, I got some stats because it was quite easy to run some database queries, and it was kind of interesting. Remember that the total amount of the users is 1.8 million, so the percentage of these accounts is quite low. But we found out that some of the users were actually setting quite easy passwords, and I don't mean passwords like password 1 or password 2. It's that people were actually setting the passwords as their first name, and it's kind of like obvious, but they were setting it more using the lowercase version of their first name, and like the full version of their first name, probably with the capital first letter. It was done like 5 times less than the password using the lowercase version. Similar thing was for the last name. It was less times. So just 500 people were setting the password using their last name. And they also sometimes used their birthday as a password. So the first format is just the international format, day, month, year, which is what we used in Czech Republic, and using the separator, the dot as a separator dot, I mean day, dot, month, dot, year. It's the local version of, it's the localized version of the date format in Czech Republic. It's interesting that just 3 people used this as a password, so that didn't matter much. We also found out that there was a lot of people using part of their emails as a password. So this foo@bar.org is just an example of the email address. But what we found out is that 3,800 people used the first part or the username of the email address as their password. And just 10 people used the full domain, but a lot of people actually used the domain name without the TLE. And yeah, we didn't run much more tests because that's what we didn't want to do. Just kind of interesting numbers for me, at least. So what we did, we took the passwords and we rehashed them using bcrypt so that they are stored in a better way in a database. What we've done that we've actually rehashed the passwords one time so that the passwords then were stored using this bcrypt show1 format. And when we are actually then verifying the user passwords, we had to first hash it using show1 and then verify it using bcrypt. But this way, it's not that nice, but at least we didn't have like show1 passwords in the database. We at least had something better. When we verify the password and we realize that actually the password is correct, we rehashed that using just the bcrypt to put it into the database so that we actually were trying to remove the show1 there, because that was kinda in the code it was creating like unwanted complications. So yeah, and when we know the password of the user that's actually verified, we store just the bcrypt version. And we realized that there is kind of a possibility of database breach. We learned it the hard way. I don't mean that our database was hacked, but we saw a lot of examples around us that the database were being hacked. So we said that, okay, let's make it slightly harder for the guys who are actually cracking the passwords. And I'm sorry for all the guys who are trying to do that. So we encrypted the hashes. We didn't encrypt the passwords. We encrypted the hashes, the final hashes, so that if somebody actually gains the access to the database or steals the database, they first need to find the private key as well to actually, or another private key, the encryption key, to decrypt the hashes, and then still they are facing the hashes, so they need to crack that. So we encrypted the hashes using AES, and yeah, that's what we have now in the database. The thing is that we had to support kind of huge amount of authentication schemes because we had, the rehashing takes some time and the re-encryption as well. Rehashing of the database took like a week, and we have to support the site running. So yeah, the code was kind of complicated because we had to support like 4 authentication schemes. Some of them were encrypted, some of them were just hashed. But yeah. So this is now how the passwords look in the database. This is actually my password from the live database. It's encrypted. You see that in the red color, it's a key ID. We support multiple keys so that we can do key rotation. We support yeah, multiple keys. And then you see IV for the cipher, and then the encrypted data. So this actually is my password. We support multiple keys also for the yeah, the database is actually shared between the production database or production servers and the dev servers, which is not nice, but yeah, that's how it works. And what I wanted is that our local development machines do not contain the production keys to the production encryption keys, because if somebody loses their laptop, there is actually the key for the decryption, and that happened. So we wanted to have different key on our development machines. So we had to support the key rotation, so that every time, every morning, the database gets reloaded from the production servers to the dev environment, the accounts are actually re-encrypted using the dev key, so that we can actually access them and use them. So, yeah. We also hashed not just the passwords, but also every token that was in the database. Because if somebody actually gains the access to the database and they see encrypted passwords or hashed passwords, and they see tokens in the plain text, I mean tokens for password resetting or permanent logins, they can just use these. They don't need the passwords to actually log in, they need the tokens. So we hashed also the tokens as well, so if somebody gains the access, then they don't actually have the tokens. And yeah, but we found out that there are some issues in the code. This is just an example. It's not the real code. It was present there. It was slightly more complicated. But yeah, we had in the code something similar to this. There was a guy trying to work around his lack of knowledge of the tool we were using. And so he introduced the SQL injection vulnerability into the code. So that's why we also tried to do the password hashing and encryption right. Yeah. Funny thing was that actually how I found out that this was in the code. I was just looking at the code base and I saw a file which was kind of with a strange name. I didn't see it before, so I just opened it and I was like, oh my fucking God. And yeah, I had to switch to do something else. I had to fix this vulnerability because I just looked at the file and I saw the vulnerability. I was not just doing any testing or just any assessment. I just saw this. So this was kind of strange for me. Similar situation was that one day we were looking at our servers. We had the managed servers, and we were looking at the servers, and there was a backup directory. So we were like, oh, what's that? So we checked that, and we saw 12 gigabytes of database backups from some other servers. So somebody, the admin of the managed server, he was doing some backups, and he forgot to delete the backups from our server. This was actually backups from some other projects he was managing. So it was databases of other users. So we were like, oh, okay, so probably we should protect our database and users as well, because even if we don't have any vulnerability in the code, our database might end up somewhere else because somebody actually might back it up some elsewhere, and they might forget about it. So yeah, that's what happened. We were kind of surprised just to find that there are some backups on our servers. So what we have done then to protect the users, we have removed the possibility. We didn't remove support agents. We removed just the possibility to set the passwords in the user profiles, because what people were doing, they were actually calling in and asking the support that, hey, I forgot my password. Can you just set the password for this account to whatever? And of course, the support agents were like, yeah, of course. Here you go. It's 1, 2, 3, 4, 5. And we're like, oh, you can't really do that. So we removed the option to actually set the password in the user profile for the customer agent. They weren't much happy. They weren't happy at all. But it's really hard to verify the user. If the user calling in is really the user who wants to change the password for. So we said, yeah, let's just not do it at all. So yeah, we changed it to the way that actually the support agents were sending just the password reset links. If somebody called in, hey, I forgot my password, the agent was like, okay, here you go. I will just send you a link where you can actually set your own password. So that looked nice, right? But the people just didn't understand why we are doing this, and they were not receiving the links. so we said maybe the links are ending up in spam folders, and we taught the support agents to actually tell the users that, hey guys, look into the spam folder or the promotions folder in Gmail, and that was fine until we realized that there is a kind of big Czech email provider who one day decided that they will outsource their AV and anti-spam systems to some other company. And this company, they were running on budget, on a kind of low budget, and their servers were overloaded. So it took like up to 30 hours to actually deliver our emails. And the reset links were expiring. We had it expiring in 15 minutes, I believe. So if the user received their emails in 30 hours, they just couldn't set the password. They were kind of locked out because they forgot the passwords. They were not able to set it using or via the customer support agents, and they were not receiving the links. So even we had it whitelisted. I mean, we had our servers whitelisted in that third party, but they just still couldn't handle our load. So we had to put the manual setting back. We had to put this manual setting back because otherwise just people were stopping using our website and were just stopping giving us our money or their money. So we had to put it back, which is not nice, but it had to be done. At least we tried to do that we log everything, every single change, and the users are actually notified if the password is changed, or if they change the password, the user is notified, so they know that the password was changed and they can react. If somebody else changed their password, they can at least react and they know about it. And we have everything logged. We know who was done, who did that, which customer support agent did that, and everything. So initially there was an issue that people were also blocking the sender of the emails. The reason was that we were sending out emails with the same sender. We were sending out mass emails like newsletters and other spam with the same sender as the password reset links. So people were like, okay, we don't know how to unsubscribe from newsletters, so we'll just block the user, the sender. And they were not receiving our password reset emails because of password reset links because they just blocked the sender completely. They said, okay, we are receiving some newsletters, we will just block the users, block the sender, and we will not receive any newsletters. But they also stopped receiving our reset links, password reset links. So we learned that with a cooperation with some of the Czech email providers, they told us that, hey, these guys actually have blocked you, and your emails are not ending up in spam folders. So marking as spam wasn't really an issue for us because the agent could tell the users that, hey, just look at your spam folders. But real blacklisting was an issue for us. So we had to set a unique sender per task. I mean, we had the same sender for, it was a no reply sender for everything. So we had to set the unique sender for password reset emails and different sender for newsletters, and actually different sender for different tasks. So, yep. We had to, I just skipped a few slides, sorry for that. We had to enable manual setting for the password in the user profiles, just because people were not receiving our emails. And what we found out then is that a third of the tokens which were coming back to us were actually already expired. So we found out that, the initial time was 15 minutes, the expiration time. We made it to 30 minutes, but we didn't see any change. It was still the same. Still a third of the tokens were coming back expired. So we found out that actually people either set their password immediately when they receive the link or when they request the link, or actually they don't do it at all, or they do it as late as next day or so. So difference between 15 minutes and 30 minutes there was none for us. What we did then, I guess that you might know this screenshot. We also moved the whole site to HTTPS because if people cannot steal passwords, they can steal session IDs, and that's it. So we moved the site to the HTTPS. We also added the strict transport security header and disabled SSL version 3. So we are getting really nice score there. And yeah, one day, also different story. Any idea what's this? It's a password, yeah. But we found out that this actually was a password of our CEO. It's not this, it was similar. I just slightly modified it to protect her. But anyway, it was this really simple password. And how we found out, I was good at looking at things and finding issues. So I was just looking at the database, and I found the table with passwords in plain text for some reason. Even if we had passwords hashed in a correct way using Bcrypt, there was an issue in the code that actually was logging the get data and post data so that we can actually track the users. But there was an issue and there was a bug in the code, and it was logging also the passwords. So we had user passwords in plain text in the database. But the funny thing was that actually not all the user passwords, but only passwords for employees, which are kind of highly valuable. So we had to reset all the passwords for the employees, because we're like, oh my God, that's not a good idea, because the backups and everything. So we reset the passwords, and we didn't reset the tokens, the permanent login tokens. But I kept receiving emails saying that, hey, I know that you reset my password, but my old password still works. It's still working. I can log in using the old password. I was like, oh, you can't really do that. So I asked the girl what was she doing, and I realized that actually she's not typing in the password. She's actually using the permanent login token to log in, and she couldn't differentiate between the token and the password. So I was like, okay, but password and the permanent login token is different thing. But for the users, they just don't understand the difference. Of course, not all of them, but some of them just didn't understand the difference. So yeah, that's some of my stories. Just to recap slightly, the problems with the real world are that you depend on the external parties, even if you don't think so. You are sending out password reset emails and everything, and that's a third-party thing. And the problems are users. They just don't understand some key concepts of the web applications, like permanent login versus signing in using password. And probably the biggest problem are the companies itself. They just don't care much about the security. Yeah, the reason why I left the company was that they said, yeah, you are doing a nice job here and protecting stuff and protecting our users, but still we want you to focus or to dedicate only 15% of your time to the security, which is not even one day in a week. So I said, okay, but you guys got a lot of issues here and I want to fix that. They said, but you should do something better, something different, like fine-tune our newsletters and everything. So I said, no, yeah, that's why I left. Yeah, and I believe that's everything from me. So thank you. And if you have questions, feel free to ask.
Yeah, all right, let's give it up for Michael here. We got a few minutes left. Does anybody have any questions?
Or if you have questions later, you can just email me or tweet me later. Yep.
One question here.
So, especially when you had your customer, you talked about your customer support people being able to reset passwords or not, or just to send out links. What kind of decision process do they have? I mean, so many sites these days have these so-called security questions, which, just due to their nature and the fact that people don't type them precisely, I'm pretty sure they're being stored in plain text somewhere.
Yeah, thanks for the question. I have a really simple answer. They don't have any. When I joined there were no processes. There was a lot of issues, like people could really call in and just reset the password for anybody. So we at least try to do something better. It's not a perfect solution, I know that, but at least we had to do something. So they don't have any procedure. They just, it's up to the customer support agent to verify the user, but they have no formal procedures to verify it. We don't have any what was that, security questions. We don't use that because to say the truth, the typical customer of this site is probably not even able to understand the concept behind the security questions. So we don't have that, or the site doesn't have that. Yeah, I don't know if I answered your question.
Except now I'm not sure at all how your customer support people make a decision to reset somebody's password or not.
Yeah, if somebody calls in, they just reset the password. They just send out the password reset link to their email address.
Okay, you've gone back to the password reset links, because it sounds like you had stopped doing that because people were getting them very delayed.
Yeah, and now I understand the question. We didn't stop doing that. We just stopped doing that only for some particular domains. We know we have the blacklist of the domains that actually these guys are not receiving our emails. So, and for these domains, these domains are allowed to set the password manually. For the others, they just need to reset the link. Send the reset link. Okay. And they are instructed to actually, send the reset links every time, except if somebody really tells them that, hey, I didn't receive the link. I know it's not a perfect solution, but we didn't come up with anything better.
Account recovery is never a perfect solution.
Yeah. Thanks.
We got about 2 minutes left. Anybody else has a question?
No questions. Thank you.
All right, looks like we're good. Give it up one more time for Michael, ladies and gentlemen.
Thank you.